This is the Cycle World podcast. I'm the editor-in-chief, Mark Hoyer, and with Kevin Cameron, our technical editor. I say that every week. Thank goodness I get to say that every week. We're back with another episode. Last one we did was two strokes. What if two strokes survived and we're running on the street? And people are reacting to that one. It's just gone up. We're excited.
Yeah.
You should check that out. This episode is sponsored by Octane Lending. It's our parent company. You can shop for a motorcycle on octane.co. There's a link in our description. Go check it out. It helps us out if you check it out. Go look at it if you're shopping for a bike. And you can show up at a dealer pre-qualified if you qualify. It's a great tool. I want to help you get the bike of your dreams. Visit cycleworld.com. Figure out what you want. Go to octane.co. Buy it. Head to the dealer. We appreciate their support. Wouldn't be happening. This show, Kevin Cameron, me buying milk, wouldn't be happening without our parent company. So we appreciate that. And hope you guys do too. On to the topic. The inline four-cylinder sport bike was invented in the 1920s. And we're talking about all the good stuff. 00 overhead cam, liquid cooling. Just a remarkable, and it was invented by two, engineering school grads, like kiddos, just wet behind the ears, just out of school. And we got a Gilera inline-four, spectacular, beautiful, awesome sport bike, race bike. And Kevin has done a remarkable amount of research on this, as you might imagine, over the years, and also for this podcast. It's a nice pile we got going here. Thousands of words. Let's hit it, Kevin. Oh, yeah, I can do that. He's rustling papers. What do you know?
Yes. So those two fellows were addressing some concerns at that time. One of the concerns I became acquainted with when I bought a 500 AJS single and found that those Englishmen who talked about big singles propelling you by firing at every telegraph post weren't far wrong. Thump. And it wasn't very comfortable. It was simple. It was inexpensive. You could afford it, but it was a rough way to go. Today's singles, of course, have balancers. They're a lot smoother operation. But what companies like FN, Fabrique Nationale in Belgium, a weapons manufacturer, by the way, built in the way of a motorcycle was an inline-four that was longitudinal. So the wheelbase was rather tremendous. And in accounts of these inline-fours, and there were a lot of people built them because they were propulsively smoother, more thumps and littler, smaller ones. So what everyone talking about those early fours has to say is that once you get a long wheelbase bike swinging, get the chassis swinging, it's hard to get it to stop. And in those early days, when motor vehicles were in the minority to horse-drawn vehicles, all the streets were covered with horse manure. So a few drops of rain, and you had a situation in which rear wheel step out was likely. And
I mean, the emissions problems with animals.
Yes. Unregulated.
Put a catalyst on that.
Beast. So the other problem was that those inline longitudinal fours were conceived at a time when engines made. People weren't concerned with the power as much as they were, is it running?
Which
means, they weren't making a lot of power. So the front cylinder and the rear cylinder they were cooled by accident anyway. But as soon as things got moving, the front cylinder was cooled nicely, and the number 4 cylinder was cooled hardly at all. And so these two gentlemen, Carlo Giannini and Piero Remor, turned the engine sideways, made it air-cooled, so that all four cylinders would have an equal access to cooling air, and therefore that problem would just be solved. And when you look at any of the great inline transverse fours, that's what you see. That they were air cooled in the early days, and they were able to cool them because the cylinders were all getting their share of cooling air. So they built then of course the long wheelbase slows down the steering a lot, so that if you have sporting intentions, you want to flop your motorbike over for a turn and not wait while the front wheel starts to move to the left, and then it starts to swing the whole chassis and the rear wheel begins to follow. You get a right now action. So, but it's strange, the kind of engine that they built. This was 1923, and over at Fiat, Guido Fernaca's experimental engineering team of brilliant people who went, when they left Fiat, as they all did, they went to other manufacturers in England and France, as well as Italy. They all did great work. And what came out of that experimental group was they had learned that the flow coefficient, that is cubic feet per minute per square inch of valve head area, was better for a single intake valve flowing into a hemispherical chamber than it was for what had been traditional during World War I, for example, for inline aircraft engines. The Germans built thousands and thousands of these. A pent roof head with the valve seated on a flat surface, two intakes on a flat surface. And so to make this work to their advantage, they looked at the biggest valve that would fit in the cylinder bore, and they were pitifully small. So then they said, what if we begin to swing the valve stems out like this, and now the combustion chamber, instead of being a flat disc, becomes a hemisphere with a lot more area for valve head. And with that concept, as well as many others, Fiat built the wonderful 404 racing engine with two valves per cylinder, and they gave it a 96-degree valve stem included angle, which means
Holy moly!
Deep chamber with a large angle between the valve stems.
That's where we get those widely splayed, beautiful overhead cam cases too. Is when they splay them out on a Hemi, it gives you that very wide and
yes, it's lovely. We grew up thinking that was the living end.
Yeah, and in
we
fact,
found
no, it's
out
not. Not so much.
They were right. Anybody that's got a Superflow flow bench can verify what Fornaca's men learned in the early 20s about airflow. Well, why do all these engines have four valves now? Because they have larger bores, and they can crush the two valve engines by just having so much valve area. Yeah, their flow coefficient isn't that great, but the area is what makes up the difference. Anyway, when Remor and Giannini did that initial thing, okay, what are the biggest valves that will fit into this cylinder bore? Instead of going the way that Walter Becchia and people at Fiat had done, namely this, they built a little alcove out over the cylinder, and they let the excess width of the exhaust valve be in that little alcove. And it looked Mickey Mouse, and it was. The engine also had a strange, massive central flywheel. See, these fellows, being engineering graduates, had not spent a lot of time with engines in front of them on a bench or on a test bench. So they were just doing the best they could. In their second try, the massive central flywheel was gone because, as all sport bike riders know, an inline-four crankshaft is the flywheel. So there were a lot of wacky things about this first engine.
Well, that alcove, I want to go back to the cylinder. What he's saying is that the combustion chamber and the valve are basically going to be shrouded. They're over the block, right?
The exhaust valves were. The intakes were all vertical, parallel to the cylinder axis, and they were within the circle of the bore, but crowded over to one side. And then the exhausts, to make adequate intake and exhaust valve diameters, the exhausts were too big for the bore. So they just built this little room off the side of the head in which the excess diameter of the exhaust valve operated. And you can see that Beccia and company over at Fiat were working on the same problem that these fellows were, and they came up with two different answers. And probably Gianini and Remor didn't have a flow bench, but it appears from history that probably Fiat did have one, because the 1920s, Harry Westlake in England began his airflow work in 1926, and I believe that the U.S. Army's Air Development Center at McCook Field in Ohio, as they say it there, was a very well-equipped research station, and I think they could. In fact, I've seen pictures of their flow rig. So the joint was a chumpin' in terms of engine design, and these two guys made a try with their own solution. They weren't happy with it. So their next engine, this had a single overhead cam and rockers. Their next engine was symmetrical, and it had incline valves and rocker arms. Their third version, how could two engineering students afford to do this?
Yeah, that's what I was going.
This is a question, because if somebody graduates from engineering school, their big problem is not how to build engines, but how to pay off 70 grand in education loans. But we can assume these fellows had some family money, and also every time they would run out of money, a wealthy count of the Italian aristocracy would show up and say, "What are you fellows doing here? Looks like you could use some help." "Why, yes." "Why don't you sit over here? We'll bring lunch." And that's how this project moved forward. And of course, what we have to remember is that today the internal combustion engine is regarded as a problem, as being reprehensible, something that should be done away with. But at the time, in 1923, the world was being revolutionized by portable power. Power for boats, airplanes, trucks, cars, motorcycles. And it was terribly exciting. This was the sort of Silicon Valley action of that time. In the textbooks, we see pictures of Otto and Daimler and all those guys looking all old and grim, like, they're having to pose for 10 minutes to get the exposure, and they look like they're on death's door. But when they were doing their work, they were hot young guys staying up for 30 hours to get their thing on test and see if their future was going to be wonderfully prosperous. So I just love it that these counts showed up at just the right time, heaven sent. And they tried to race the things, but it was a tough one, because one of the most expensive things to create is reliability, because reliability testing means designing a test method, running your engine until something fails, analyzing and then redesigning the failed part and resuming the testing. And in the early days, everything failed. So an enormous amount was learned. And the persistence of these people was marvelous. Of course, you could see that in the early days of the semiconductor world, because the yields, each time they would increase the number of switches that they could put on the silicon chip, when they would begin manufacturing them, the yield would be like 5%. And so they had to do a tremendous amount of R&D in order to reliably transfer the design to the physical reality of the chip. And the same thing with internal combustion engines. The connecting rods break, bearings seize, bolts stretch, all these maddening things. Well, we'll just have to keep on pushing. So at some point, these young fellows got in touch with Piero Taruffi, and he wrote a little red book, which I bought a copy of when I was in college, about the art and the technique of motor racing. And it's actually got a lot of great stuff in it. Taruffi was called the Silver Fox because he had prematurely wonderful white hair. And he knew everybody, including Mr. Gilera. And there got to be talk about, well, do you suppose this four-cylinder thing might have actual merit? And would you like to buy our whole project? And in the end, supposedly, Mr. Gilera said, give me one reason why I should even look at this thing. You guys can't finish races. You're nowhere. So they re-intensified their efforts, and they came up with an improved design of liquid-cooled, supercharged, transverse four-cylinder, and a whole race bike. And it was quite modern looking. The chassis made you immediately think of Rob North and the Triumph BSA triple racers. And the cylinders were leaned forward 60 degrees to make room behind them for a 3-lobe roots blower, which blew like 5 or 6 pounds of boost into the intakes. And in the early days, they were making 60 horsepower at 8,500 RPM. And these aren't very exciting numbers in hindsight, but you have to realize that they were doing this at a time when 500cc racing singles were making 38 horsepower. So they're bearing down on this. Taruffi and another rider take the bikes, they built 6 of them, to the Libyan Tripoli Grand Prix and finish 1-2. And that was enough for Mr. Gilera. He said, come here, boy, gonna make you a star. And with real R&D help from a professional organization with all kinds of machine tools and welders and fabricators and all the good stuff that you need for R&D, they were able to win the 1939 European Championship, which was the Ulster TT, basically. And they not only defeated the supercharged BMWs in Sweden and Germany, but at the Ulster, Dorino Serafini, I love those Italian names because they all sound like they were composers and artists. That's where I've seen the names like that. The names are so musical. Serafini would pull up alongside whoever his rival was at the moment, look over grinning, and then just turn the throttle and effortlessly pull away. So,
Infuriating.
yes. But what they had done was they had made an unreliable lash up of ideas that were not necessarily all properly thought out and coherent. They had made it into a usable machine that you could say, air up the tires, put in the gas, check the oil, let's go racing. And that's what you need. It is a romantic idea that people stay up all night the night before the race, and the engine is spread out on the floor of the van, and parts are rolling away. And occasionally these things do work, but you wouldn't want to live your life that way. Or as Bud Axlin, who was a longtime associate of Kenny Roberts and who worked on Yamaha and Suzuki cylinder and pipe R&D programs, once said, he said, yeah, all-nighters are a part of racing, but I don't want to live there. And your race bike doesn't want to live there either. You want something that is solidly reliable. The materials are good, the heat treat is good, the surface finishes are good. You've been through all those problems, and now you know that if you put the thing together according to these protocols, it will run. And they talked about crankshaft life of 50 to 100 hours. This is wonderful for a race machine. So, whereas for a TZ750, we thought we were doing well if we got 950 miles out of a set of cranks. This was a roller engine because the plain bearing revolution was yet to come. And Gilera funded efforts to get a crankshaft that would be solidly reliable. They tried split and bolted rods on a one-piece crankshaft with hardened journals and all these rollers. They tried it with caged rollers. They tried it with crowded rollers. They had the German Herth firm, which made radial spline couplings that can only go together one way, and they require fanatical machining accuracy, so they're quite expensive. They tested with those. They tested with pressed together crankshafts that were simpler, and that's what they ran most of the time. For practice, for example, always a pressed together crankshaft. But the point here is that they went through all the steps to make a reliable engine. It's not enough to have promising drawings. And what happened during World War II is that there were several outfits, Continental, Bendix, Chrysler, built promising aircraft engines in prototype and couldn't make them reliable enough for use at any time during the war. So their priorities were clicked off. The buildings that had been allocated for their manufacturing were reallocated. And they were basically told, stand over there, there'll be a bus along to take you to the dump. Getting reliability is a very demanding operation. The U.S. Navy, who had the problem of explaining to the parents of young men who went into the drink because their aircraft engines in their carrier planes were unreliable, they insisted on testing to destruction. And their method became the standard of the engine industry. Run it till it breaks and just keep doing that until it doesn't break. And Pratt and Whitney looked at it, they took this a step further. Their method they called trampling problems to death. When a difficulty would show up, for example, studs breaking because the parts that the studs were holding together were flexing, they would have a meeting, decide on all the approaches that they could think of to solve this, and then they would take action on all of them. They would work on all possible solutions simultaneously. This wouldn't go over in the automotive industry.
I was going to say, if you have well, it reminds me of something that Dan Gurney said once All American Racers got into aerospace.
Yeah.
And they were, they built flying machines and had a huge, huge ovens to do carbon fiber that were, like 100 feet long or more. It's just all this stuff.
Yeah.
Big autoclaves. And Dan said, he said, well, I really feel like Justin Gurney, his son, saved the company when he got us into aerospace, and once we got the government as a customer, it turns out the government's a very good customer. And so that's when you want to trample problems, it does take
well, of course, this method of trampling problems to death is applicable when time has become more valuable than money. So, for example, here's our prototype engine. We want the Department of Defense to buy 100,000 of them for their airplanes, but we can't make it reliable. Then they're not going to buy any of your engines. So you have to do that method because it's the method that's going to work. And of course, the European War began in September of 1939, and all this activity came to an end. We've seen before how the machine tools at Bruff Superior were used to do finish machining operations on Merlin V12 aircraft engine crankshafts. So all this resumed once the war was over, once all of the wreckage of the many B-24 raids on Italian targets was cleared. They came up with a design for an air-cooled four-cylinder racer. And the FIM had decided that supercharging was too expensive for the depressed post-war economy, so they said atmospheric induction only, meaning atmospheric pressure is all you've got to fill your cylinders. And early on, grand old man of Italian racing, Nello Pagani, won the Italian 500cc championship on the Rondine without a supercharger, and the poor thing was all it could manage was 48 horsepower. But he did win the Italian championship, and then all of that went to the museum. So this new engine had a dry sump. It was air cooled. It had valves swung apart 100 degrees, and it had the steepest, tallest, most ecclesiastical looking piston domes you can imagine. It just looked like the flame kernel from the spark plug, which is right in the center between the two valves. It's not the tip of the spark plug sticking down there. There's a rectangular spark port, which means compression had to push some charge up in there and get it ignited. But imagine this terrifying piston dome, flame trying to spread around it. How much ignition timing did they need? 60 degrees before top dead center. So intrusive and so contrary to what would later be seen as fundamentals. Those deep hemichambers and tall piston domes were just awful. But Gilera had an endless program of improvements. They started out with girder fork and rear suspension with a dry friction damper with a big wing nut on it. There, a quarter turn, that ought to do it. And
So much
because
sticking friction, so
these
much
people,
fiction. Yeah.
yes, they couldn't phone up Jeff Fox and say, "Get over here and solve all these problems." So, but every time the bikes would appear, there would be an increment of technology. And at first, it was Piero Remor, originally the student of 1923, but he huffed off at the end of 1949 because it seems that um, there was only one opinion that he could listen to, and that was his own. And also, it was he did not understand the partnership of the engineer and the rider. The rider is giving this wealth of understanding. When I'm lifting up out of turn 7, this thing starts. And you need sympathy at that point because the engineer's life is not at risk, it's your life. So they made this rapid progress. They got rid of the girder fork and they put on telescopics. And once they had telescopics, they tried that for a while, and then they made the tubes bigger and stiffer. And at another point, they thought, what if we make the upper and lower fork grounds into one unit of welded sheet steel that has tremendous torsional rigidity, and then we slid the tubes up in there and clamped that up? That ought to be pretty good. Some of the bikes are built that way. I saw one of them like that. I stumbled into a sort of Gilera retrospective at Monza. So what happened when Remor left was that instead of hiring another haughty, I can calculate that type from a university course, Mr. Gilera promoted Passoni, who had previously been a technician and a mechanic, and Alessandro Colombo to be the project engineers. And they were not haughty. They spoke to riders. They were willing to listen to reason. And when the prototype was first tested, it weaved terribly. It couldn't reach its maximum speed. This is why Cook Nelson was able to win the 1977 Daytona Superbike race on a Ducati, making not all that much horsepower against the Japanese transverse fours, making 120, 125 horsepower. Their chassis weren't good enough to go straight to their top speed. They would start this, and that oscillation can diverge, and suddenly you're on the ground, and your breakfast comes on a tray next morning. So these problems were overcome, and the model that they had to guide them was Norton, because for the 1950 season, Norton were out of ideas. Their racing motorcycle with its single-cylinder Manx engine, the frame was called the Garden Gate design. Garden gates swing back and forth in the wind, and that's the way it's felt to riders. So they'd heard of these Irish brothers, Cromie and Rex McCandless up in Northern Ireland. They had been experimenting with a Triumph-powered motorcycle and running it on all kinds of terrain and trying all kinds of stuff. And they said, we'd like to give you fellows and your ideas a try. And they built a twin-loop chassis with a swing arm, hydraulic damping, smooth, creamy hydraulic damping at both ends. And Norton tested it every way they could. They took the bikes to the Isle of Man and tested them against the Garden Gate bikes. They took them to the MIRA test track. And I
Myra.
think, yeah, they took them somewhere else. I don't remember what it was, but once they were satisfied that the new chassis were better, such as the rider on the McCandless bike being able to pass on the outside, the Garden Gate models, they said, okay, well, you have to come down here and build all the frames because we don't have any welding equipment here at the factory. All we do is cast lugs raised by smearing spelter, powdered bronze, and flux in the holes and sticking the tubes in the holes. The whole thing goes into the oven.
Yeah, they sweat it in there, and there's
Furnace brazed.
yeah, there's SIF bronze welding. Is that what we're talking about? I think.
Well, SIF is that silver alloy, and it melts at a very low temperature so that the metal that you're bonding is not red hot. And that's what the McCandless brothers used to make Norton's frames for the 1950 TT. And the
Well, a lot of
frames
the
were
tubings, when you were getting that rental tubing, lightweight, very strong, but not temperature resistant, would become brittle. Some of that. I'm not saying that
okay. Yeah,
the Norton
yeah,
frames were like that, but I know the front frame on a Jaguar E-Type, for example, uses a square tubing, and it's not electric welded together. It's glued together with brazing.
yeah,
Because of the quality of the tube would be weakened by the heat.
yeah,
I've seen the
yeah,
videos, they made black and white films about the British industry forging ahead in in the 50s, and they went into the Triumph factory, and you see essentially like probably a coal pile with a blower under it, and a big guy with a leather apron, stuffing tubes into lugs, and then sticking it in the fire and taking it out and sticking it in the fire and then hitting it with a big hammer to straighten it
yeah. To
out.
seat the tubes.
Yep.
They Rex McCandless worked for Short Brothers Aviation up in Ireland, so he was familiar with all this new low temperature brazing and so forth. And he built the frames for the 1950 TT. He also made the rear suspension units out of Citroen parts, which were hydraulic dampers. And you can see in the photos made in the shop underneath the hotel where they were staying, these shocks had remote reservoirs on the side of them. Very modern looking, but 1950. So the McCandless brothers were a real find for Norton. And what happened in 1950 is that despite the Nortons making very low power in the high 30s because of the still terrible gasoline that you could buy, which was like 76 octane, and the fact that the Gileras were making more than 10 horsepower more than the Nortons were winning races when the Gileras were not. And Jeff Duke, who was having his first season in Grand Prix racing, fresh-faced boy that he was, suffered tire tread separations because these motorcycles were moving right along, and the tire technology of that time was cotton and glue, jumped up glue, and Gilera was able to win the 1950 World Championship. AJS had won the 1949 championship. And then in 1951, Norton had switched to Avon tires and didn't have any more tread separations. And Norton singles ridden by Jeff Duke, 500cc World Championship against four-cylinder opposition. Now you can imagine how humiliating this must have been for the Italians. And the likely response of the "I can calculate that" group would be to try to do it better some completely other off-the-wall way. But the people at Gilera just Nortonized their motorcycles. They got rid of girder forks, they adopted tellies, they got rid of dry friction damping, substituted hydraulic damping. The early dampers were terrible. They overheated and the damping went away. So that, as Jeff Duke says, we would set these German Stürcher units extra hard at the beginning of the race, figuring that they'd be pretty good at half distance and completely functionless at the end. In the middle, you could get something done. So they kept making changes to the chassis. For a long time, the chassis was two loops on the bottom and a backbone at the top that split in two. And if you look at a AJS 7R or a G50 frame, it looks a lot like that, with the backbone and the two loops under the engine. They went on with that for a while. And then in the final 2 years, in 1956, they came up with a different frame that looked entirely modern up to, say, 1978, when the steering head had tubes going from the top and the bottom back in a long triangle, nearly to where the seat tubes were going out to attach to the shock absorbers, and twin loops under the bottom. Real modern bracing of the steering head, because another area in which Gilera were forced to develop solutions was brakes. Because as their 48 horsepower engine became a 53 horsepower engine, and then a 60 horsepower engine, and finally a 70 horsepower engine, with full streamlining, those motorcycles weren't coasting to a stop anytime soon. So Duke and the others riding the Gilera were braking very hard. And at one point, they had 2 weeks before a race where that was very demanding on brakes. Gilera had a bigger brake, a 250 millimeter double-sided brake, designed, castings poured, machining done, friction material riveted to the four shoes, and the brake was a satisfactory functioning unit within 2 weeks of not having existed at all. So these people were serious and they were straightforward. And this is something that you find in aviation development. The big thing that Lockheed is credited with is discovering that when your program is over budget and behind schedule, you don't add engineers to the project, you take them off. Because what they discovered was communication is a major problem in an engineering undertaking. Oh, well, we'll have to have a meeting for that. Well, who's got to be there? Well, we want to tie up as many departments as possible. I mean, that's the end result, is you're sitting in a meeting thinking, I'm not going to get a damn thing done all day. Whereas if each person is madly pursuing his own deal and talking about it with others over lunch, you might actually accomplish something. And I think the French company Dassault made a similar discovery. I'm sure it's general in the aerospace business that if you're over budget and behind schedule, take engineers off, because the more engineers there are, the more internal human friction in the project. And I think Gilera had come to a good way of working. in the years between 1949 and when the big Italian pullout from GP racing occurred at the end of 1957. Because I looked at these numbers at one point and isn't that in this book? And I'd look it up. It turns out that the German motorcycle industry that had exploded into massive production, NSU became the world's largest motorcycle manufacturer in the early 50s. And in 1955, German industry began to produce Volkswagens. What Germans wanted was transportation. And if there's a new form of transportation that's dry when it's raining, it's warm when it's snowing, that's where you're going to put your money. So that the German motorcycle industry just nosedived practically to zero, and the only survivor was BMW. There were some great names like Horex and so forth that were heard no more. And in England, it was 1954 when AMC, Amalgamated Associated something or other motorcycles, which owned Matchless, AJS, and Norton, were forced to say, okay, no more GP racing. The kind of GP racing that they were doing was so low budget that what they would do is show up at the train station with their bikes wrapped in padding so they couldn't be damaged by the freight handlers. They would say, here's a destination for all this stuff. And then they would go into a passenger car and sit in their seats and be taken to wherever the racetrack was in Europe. And when they got there, the local dealer would show up with a truck and take them to the circuit. So there were no 45 footers. There were no riders flying in their own twin engine planes. All of the marvelous excess of the present day in sports. It's sort of entertaining to watch it.
Well, they have an entire, truck. Everybody does dedicated to catering.
Sure.
Just it
Yeah.
pops into a beautiful restaurant that has the finest food.
You walk down the main drag at Valencia, and on your left, as you come in the gate, is this long row of gigantic trailer trucks, tractor snouts. They're all there like this. My radiator cover is flatter and more intimidating than yours. And behind those tractors are these 45 footers at each garage. And on the other side, like Mark says, the hospitalities, some of which are marvelous things that unfold with electric motors and become substantial restaurants. And they have some pretty good food in those places.
Oh gosh, I've had a few meals. It's amazing the stuff you get out of there.
It is just a miracle. People say to you, you're hanging on to the coattails of some factory character, and he said, "Come with me, we'll get lunch." Oh yeah, and you know what it's like to get lunch at U.S. tracks. But if you're a privileged insider, and
Same
you
as the
go in,
Alaman TT, different names, same triglycerides. Fried food, baps, sandwiches,
so
sausages, you name it.
it's just wonderful excess. And of course, you look around. That's all the heavies, the team managers, the riders, their psychologists. Quite marvelous. Anyway, all those companies, the Germans, the Italians were out at the end of 57, except for MV, the English, and MV were sort of in sole command of 125 and 500 GP racing, and then 350. And MV just won a stack of races without much opposition. And the English journalists, without deviation, referred to them as the all-conquering Italian fire engines.
Yes, of course.
All-conquering. And of course, during that period, they didn't need a lot of R&D. MV didn't do a lot of R&D until it became clear, 1966, Honda's got a 500. Our junk wagon can never deal with that 85 horsepower modern aero. So MV came up with the triple. And this is another interesting point. The last 2 years, Gilera moved the rider ahead 4 inches. The Norton Manx had moved the engine and the rider forward about 3 inches. This was a salient point of its superiority over the Garden Gate, because you could begin throttling up a lot sooner than the guy who had less weight on the front end.
Well, it's a point that we've discussed before with, the streamline era of having the very long. So in the streamline era, you could make your motorcycle a torpedo with a fairing that went out and basically enclosed the front wheel. And they eventually made that illegal. But some of the teams took the fairings off and then started the race, but they had compensated for the weight bias of having that fairing sticking it way out, and then there was no weight on the front end. I'm still thinking about what you said about a 70 horsepower streamlined motorcycle.
Yeah.
And how fast that would be. A 570 horsepower 500 is no joke. And the streamline that, I can't imagine the speeds. And then as you were talking about braking, I'm also thinking about the reliability question where you said a TZ 750 crank, you felt lucky to get 950 miles, which would be what, 9 or 10 hours maybe?
Yeah.
Like 10 hours, and you're getting 6 times that out of a Gilera 4. You're getting, which,
well, of
what
course,
you said,
being a 4-stroke does have positive lubrication. So,
yeah,
and the big ends aren't
fair
operating at
enough.
400 degrees.
Fair.
Okay,
fair.
Yeah.
Still, I mean,
sure. And we know that Kawasaki Z1 was a roller crank. The GSs were roller cranks. They were just putting a few toes into the future at a time. The weird thing about the Kawasaki Z1 is it had this 1950s roller crankshaft, but upstairs the camshafts ran on replaceable shell plain bearings. And so, nobody's offered me a copy of their R&D notes, their planning documents.
well,
But all we can do is speculate.
Yeah, I just want to take apart something like a Gilera 4. I want to find out what the piston clearances are and really get a look inside. We have,
there's a great story that I remember reading in book after book and website after website that Gilera had this problem in the late 40s with piston breakup. It would happen without warning, and the piston would just break up into many pieces. So I sent Bruno De Prato that question. What
he's
gives
our
here?
European contributor. Bruno De Prato is our European contributor, and he's Italian. He worked at Ducati and brought super blend bearings in to increase the reliability of Ducati engines in the 1970s, the V-twins. And Dr. Taglioni was his best man at his wedding. So Bruno knows some folks in the Italian industry.
He knows some folks. Yes, sir. Well, I asked him, what gives with this piston breakup? And then it disappeared, and there's never been any explanation. He said, yes, that's a worthwhile question. He said, I'm going to see if I can get in touch with that sourpuss Colombo. And he calls me back, or he emails me back a few days later, and it turns out that, like a lot of companies in those days, Gilera wanted to make everything for their motorbike, including the pistons. So, because they did not have an up-to-date piston design operation like Borgo or Mala or Hepworth and Grandage, uh, they would make the piston cylindrical. Well, of course, the top of the piston expands more than the skirt. The skirt is touching the cooler cylinder wall. The top is exposed to combustion. So, seized. That's 12 times this week. Do something. So
Well, even yeah,
they
even
increase
with
the
the
clearance, and we've all had somewhat similar experiences. You build a rattler and it doesn't seize, but it breaks the pistons.
well, even in the best conditions with a campground piston that has the the
It's oval, it's tapered. Yes,
oval and tapered to work in the bore, uh, Manx 500 Manx would be 13 thou.
really. Well,
Yeah,
it's a fortune.
I was talking to Brian Slark, and he was saying, yeah, I'd set my Manx up at 13 thou because I had a Triumph, I had a desert sled Triumph, a 58 Triumph Trophy that somebody had kind of hotted up a little bit, and it had like 11-to-1 compression pistons, which is quite a bit for an air-cooled Triumph motor.
You bet.
Huge domes, because it's a hemispherical head, huge domes filling the Hemi head, and those were 11 thou clearance. And I thought, well, this has to be a mistake. And then I was talking to Brian, because Brian had sent some Ferrari like 156 pistons, where the dome on those shows your 90 to 100 degree flats where the piston is cut out for clearance. And so that's how we got on the subject. But yeah, 13 thou. And if you make a piston round, which I discovered, I'll say it, folks, Velocet. When I first got my 500 Velocet, it had been rebuilt by somebody down in New Zealand, and they sleeved the alloy cylinder. This had a Alphin, aluminum cylinder with an iron liner. They re-sleeved that liner, and they took the piston that was oversized, being the thrifty, clever people they are, and but unfortunately put the piston in a lathe to cut it down. When that seized, I was like, well, why did this seize? And I took the engine apart and I measured the piston, and the bore wasn't round. It was tapered. It had waves in it. And there were many other things. The deck was out 5 thou from the factory. I'm pretty sure the engine case had been welded together 12 thou. The drive side main bearing boss had been welded in 12 thou out. So I had 17 thou out of true between the cylinder and the crank. All of these things were wrong. The only thing that was actually round in the engine was the piston, and it shouldn't be. And
Yeah,
that's why
and it shouldn't be.
and
Yeah,
that's why it seized. So
because when I began to understand a little bit about pistons, I wanted to measure a bunch of them, and you find that the skirt, the least clearance is down at the bottom of the skirt because the skirt has a slight taper because the bottom of the skirt is cooler than the top. So there's a slight taper on the skirt, and then you get to the ring belt, and it just dives inward because the heat is going to expand to the top of the piston more. Anyway, what Gilera finally did is said, okay, we can't make the pistons that will work. We give them enough clearance not to seize, they shatter. And so they went to Borgo, and Borgo had all the diamond turning and taper and oval stuff. And they said, okay, here, these pistons should work better. And they did. And Gilera went on to win a large share of the 1950s 500 championships. And in 1963, I think Scuderia Duke persuaded Gilera to let them run the 1957 bikes, which were sitting in a bank vault somewhere, and they were still competitive because MV had no competition after 1957. I mean, why would you improve your motorcycle if it wins races with ease? So that was the era of the Italian, the the unstoppable Italian fire engines. It was a bit of a distortion because MV from 57 on didn't have much competition. Not until Honda arrived in 66 and 67, at which point MV rose to the challenge. They put everything they could gather into this motorcycle, move the motorcycle, the rider forward, move the engine forward, lighter weight, more flexible torque curve. They did a lot of things right, and they won both of those championships against Mike Halewood on the mighty RC 181 Honda. So,
But it's fair to give Gilera credit for cross the frame inline-four,
absolutely,
and then forging ahead with chassis improvements to match that horsepower that they're making.
yes, which would
The Augusta,
otherwise have been pointless.
yep, MV Augusta carries the torch.
And then
Honda comes to the party, and in 1969 we get a Honda CB 750 inline four-cylinder motorcycle that we
and
can ride
Honda
on.
had taken care to put the words Honda 4 on the lips of millions of people worldwide because Honda had made a name for themselves. That's what that GP racing was for to create a household word.
Well, we even
Honda.
got sixes out of it eventually.
Yes, sixes, fives, you name it. So, but it's fascinating to me to see how these projects, which often begin in a sort of amateurish, cobbled together way, um, they either learn as they go, or somebody like Piero Taruffi, who knew everybody, says, "I got somebody who wants to have a look at your project. Might make a few suggestions if you wouldn't be insulted." I'm just imagining this, but in both cases, the pre-war Rondine, um, I had the I went to one of those pronunciation websites, so it's definitely 3 syllables.
Well, that's cool. What he's saying in English is Rondine. That's how we
Yeah,
would.
and
That's
that's
how
how
we.
it's spelled. It looks like it should be Rondine.
So if you want to
And
Google that,
yeah,
yeah,
Rondine sounds like it should be a Chuck Berry song.
it does.
But they um, gathered momentum, they gathered sophistication, and they were able, both pre-war and in the early 1950s, to professionalize what they had built and make it solidly competitive and then dominant. And this is one of the things that's very difficult. Phil Schilling, the late Phil Schilling, once said that it is unfortunate to have to rely upon a wealthy sport for sponsorship because this person's wealth presents him or her with so many attractive alternatives that if your project doesn't tickle the fancy, uh, it's canceled. You haven't been returning my calls. Yeah, I've been busy with other things. Look, I'll call you back. I'm busy right now. That's it. Project over. But it's so delightful to see that pre-war transverse four, which amateurish though it was, evolved into something solid enough to win the Tripoli Grand Prix, justify Gilera's desire to have a racing machine, and then to have that design become solidly reliable. Same thing post-war.
Out of the
Oh,
gate,
Yeah.
Out of the gate, they just made it. They just built it. I was talking to Gary Braun, who you know. Gary's
Yes.
he's a two-stroke pipe maker, engine builder. Had a company that he was running himself called Retrodyne, and he was making chambers and doing other machine work and so forth. And he works for Millennium Technologies now. I showed him I've got the Yamaha racing parts book, and I showed him drawings of the cones, because they give you pipe designs in this book to hop up your RD 350 or whatever, TD1, TD, whatever it is, and they give you these pipe designs. And I showed it to Gary, and he says, I used that drawing to make my first pipe. And he made it out of the wrong material. Like he kind of told me the story about how all of this went. But I said to him, the important thing is you made a pipe. You
You
made a
weren't
pipe
discouraged.
and it didn't work. And the next pipe was different. And that's all we can ask for from
Yes.
somebody who wants to make things.
They're bringing it forward.
Make something, don't plan forever, make something, and it doesn't work, well, change it and learn from it. And I think that's what's so inspiring to me about the Gilera program, is it was sort of shooting for the moon with this inline-four, and they did something that people weren't doing. They turned it across the frame, and it had a flywheel, but then it didn't have a flywheel. And then we can't make our own pistons, let's just get somebody else. I just that's what I love about racing, is that when people pay attention and do the engineering that
Is required.
is required, it just changes and things evolve and we get better. And now we have 220 horsepower street bikes, 200 horsepower street bikes with electronics and aerodynamics that actually work. I mean, we're getting aero on BMWs and Ducatis that is from the racetrack.
Now, in that 1950 season when Jeff Duke had tread separations, that was the state of the art in tires. They could not quite get 40 horsepower to the road through one tire. Today in MotoGP, they have essentially 300 horsepower, and they have come up with methods of getting that power to the road through a single tire. So that's an enormous leap. 300 divided by 40 times more power. Now, of course, the tires have improved. They've become larger too, but it's really remarkable that such a change could occur, but you just keep pushing. And that's why in every race, if you can get to the garages, you will see the rider sitting like Christ at the Last Supper, surrounded by his disciples, the electronics guy, the tire guy, the suspension guy. And the rider is saying, I don't know what to do about this. And there we are in turn 7 and all this stuff is happening. And they conference. Oftentimes a journalist has made an appointment through the management to talk to a rider for 10 minutes. He can't make it because he's still in conference. At the end of the day, this is important stuff because this is where the understanding that leads to progress. That's where we learn to ask nature the questions that can let us move forward.
Well, and you get the new problem because you solved the old problem and it moves the problem somewhere else. It's like when Gianini said for Ducati, Gianini said, the principal problem is the wheelie. Before they had aero, the principal problem was the wheelie, and they had to solve that problem because they had 300 horsepower or whatever it is, all of the horsepower and traction, and they had a tire that could put it to the ground, and they were losing time because the bike would wheelie everywhere. So what do we got to do?
Be able to steer.
Yes.
Sort of fundamental.
In any case, it's a mad respect to Gilera and all it accomplished. And as we said in the beginning, inventing the inline four-cylinder sport bike, even water cooling it when it was supercharged. We have all the elements were there. They evolved the chassis to 1978 standards, as Kevin pointed out, and just a wonderful piece of
It's a
history.
great story, and having to study it so that I wouldn't sit here with my mouth open and nothing coming out.
That's my job.
I could see this wonderful progress that I had not known about in detail, that they had attended so many details, one after another, and that's what it takes.
Well, thanks for listening, folks. That's Gilera for you. I'm Mark Hoyer with Kevin Cameron. Once again, check out the link in the description, octane.co. Octane is our parent company and sponsor, and we wouldn't be here without them, so check it out, and we will catch you next time.